Imagine stepping outside, and there's no air, no wind, no sound. The sky isn't blue anymore, it's black at noon. Within seconds, you can't breathe. Within minutes, most life on Earth is gone. This isn't a sci-fi movie plot. This is physics. What if Earth lost its atmosphere? Before you say, that could never happen, pause. Earth's atmosphere is just a thin layer of gas clinging to a rock because of gravity. That's it. A fragile envelope about 100 kilometers thick, although most of the air we breathe is packed into the lowest 10 to 15 kilometers. Compared to Earth's 742-kilometer diameter, it's thinner than the skin of an apple, and it weighs about 5.15 quintillion kilograms. Massive, yes, but in cosmic terms, paper thin. So let's interrupt your expectations right now. If the atmosphere vanished instantly, you wouldn't freeze solid immediately. That's a myth. The first thing you'd notice wouldn't even be the cold. It would be silence. Sound cannot travel without a medium. No air means no sound waves. Cities would fall eerily quiet. No traffic, no voices, no birds, just absolute, crushing silence. Then, within about 10 to 15 seconds, you'd lose consciousness. Not because your blood boils explosively like in Hollywood, but because there's no oxygen pressure to push O2 into your bloodstream. At sea level, atmospheric pressure is about 101 kilopascals. Remove that, and your body can't absorb oxygen. You'd black out fast. Here's the controversial truth. You wouldn't instantly explode. Human skin is strong and elastic. But without pressure, the water in your saliva, tears, and the moisture lining your lungs would begin to boil at normal body temperature. This is called ebullition. It's been observed in vacuum chamber accidents. Survival time without a pressure suit? Roughly 90 seconds before irreversible damage. Now zoom out. The sky would turn black immediately. The blue color we see is caused by Rayleigh scattering, sunlight bouncing off air molecules. No molecules, no scattering. Even at noon, you'd see stars. The sun would appear harsher, sharper, more dangerous. And dangerous it would be. Right now, our atmosphere blocks most ultraviolet radiation, all X-rays, and most harmful cosmic radiation. The ozone layer absorbs the majority of UVB and UVC radiation. Without it, the surface would be blasted with lethal radiation within minutes. Sunburn wouldn't take hours. It would take moments. But here's where it gets even more dramatic. Temperature. Most people think Earth would instantly become an ice ball. Not immediately. Air doesn't hold heat the way you think. Land and oceans store far more thermal energy. For a few hours, temperatures wouldn't plummet drastically. But without atmospheric insulation, things would change fast. The atmosphere acts like a thermal blanket, trapping heat through the greenhouse effect. Without it, Earth would behave more like the moon. On the moon, daytime temperatures can reach about 127 degrees Celsius, while nighttime temperatures drop to around minus 173 degrees Celsius. Earth would start developing those extreme swings. During the day, direct sunlight would heat surfaces intensely. At night, with no air to trap heat, warmth would radiate straight into space. Within days to weeks, the global average surface temperature would begin falling dramatically, likely stabilizing far below freezing. Now let's talk about water, because this is where reality becomes almost unbelievable. Liquid water cannot exist without sufficient atmospheric pressure. The triple point of water is at about 0.01 degrees Celsius and 611 pascals. Below that pressure, water can't remain liquid. It either freezes or sublimates directly into vapor. Remove the atmosphere, and ocean surfaces would begin to boil, not because they're hot, but because the pressure is gone. It would look like a cold boil. At the same time, the oceans would rapidly lose heat and begin freezing from the top down. Over time, Earth would become a frozen world, with vast ice layers covering what were once oceans. Some water would sublimate into space. Some would remain locked as ice. Plants would die almost immediately, not just because there's no carbon dioxide, currently about 0.04% of our atmosphere, but because they'd be exposed to vacuum and radiation. Photosynthesis would stop instantly. Animals and humans, unprotected, would follow within minutes. Insects, some microscopic organisms, possibly a few extremophiles might survive temporarily in protected environments, deep underground or near hydrothermal vents. But surface life, as we know it, would collapse almost instantly. Here's another overlooked consequence: meteors. Every day, about 48 tons of meteoritic material enters Earth's atmosphere. Most of it burns up due to friction with air molecules. Without an atmosphere, even small meteoroids would strike the surface directly. Earth would suddenly resemble the moon, slowly accumulating impact craters. And satellites? Ironically, many would stay in orbit longer. Right now, low Earth orbit satellites experience atmospheric drag. Remove the atmosphere, and that drag disappears. Some satellites would remain aloft for decades or centuries longer, silent machines orbiting a dead world. Now let's challenge a deeper assumption. Is the atmosphere permanent? No. Earth's atmosphere has changed dramatically over billions of years. Early Earth had almost no oxygen. The Great Oxidation Event, around 2.4 billion years ago, transformed the planet when photosynthetic microbes began releasing oxygen. Oxygen levels rose, reshaping life forever. And in the far future, the atmosphere will change again. As the sun gradually becomes brighter, about 10% more luminous every billion years, Earth's climate will shift. In roughly a billion years, increased solar radiation could trigger a runaway greenhouse effect, evaporating oceans and eventually stripping much of the atmosphere away. So while a sudden loss of atmosphere is extraordinarily unlikely under current conditions, thanks to Earth's gravity and magnetic field protecting it from solar wind, over astronomical timescales, atmospheres are not guaranteed forever. Look at Mars. Evidence suggests it once had a thicker atmosphere and liquid water. But with lower gravity and a weak magnetic field, much of its atmosphere was gradually stripped away by solar wind over billions of years. Today, Mars' atmospheric pressure is less than 1% of Earth's. The controversial takeaway? Our atmosphere is not just air. It's a life support system more complex and fragile than most people realize. It regulates temperature, shields radiation, enables liquid water, allows sound, protects us from space debris, and provides the precise chemical balance life evolved to depend on. Roughly 78% nitrogen, 21% oxygen, and trace gases like argon and carbon dioxide. Remove it, and Earth doesn't just become uncomfortable. It becomes almost instantly uninhabitable. No breathable oxygen, no stable liquid water, extreme radiation, violent temperature swings, constant meteor impacts, silence. A world that looks eerily beautiful from space. Blue oceans turning white with ice, continents sharp under a black sky, but utterly hostile to life. And here's the pattern interrupt you didn't expect. The scariest part isn't how dramatic the end would be. It's how dependent we are on something invisible. You can't see most of the atmosphere. You don't feel its weight. Yet every breath you take depends on that thin, delicate layer wrapped around our planet. 5.15 quintillion kilograms of gas, held down by gravity, protected by a magnetic field, balanced by biology and chemistry over billions of years. If that disappears, so do we. So next time you look at the sky, remember, that blue isn't just beautiful. It's survival. If you found this perspective mind-bending, follow for more deep dives that challenge how you see our planet and the universe around it. And here's the question I want you to think about. If Earth's atmosphere is so fragile and essential, what do you think is the single greatest threat to its long-term stability? Natural cosmic forces, solar evolution, or human activity? Let's talk in the comments.